In this video, we want to find the limit as x and y approaches 0, 0, x to the fourth plus x cubed times y squared plus y to the fourth all over x to the fourth plus y to the fourth. And notice if I plug in 0 for x and y, I get 0 over 0. So I want to somehow change this fraction up by splitting it up and simplifying it. So what I'm going to do is break it up into two fractions. The first one, we have an x to the fourth plus y to the fourth on the top. That's going to be all over x to the fourth plus y to the fourth. And then what's left is x cubed over y, x cubed times y squared. And so that's going to be over x to the fourth plus y to the fourth. Now the first fraction just cancels and you're just left with 1. So we need to find the limit of x cubed y squared over x to the fourth plus y to the fourth. And so here we want to be clever and use a squeeze theorem. So we're starting off with x squared minus y squared, quantity squared. We know that's always going to be bigger than or equal to 0. Since a square is always bigger than or equal to 0. And so if I multiply out the x squared minus y squared squared, I end up with x to the fourth minus 2x squared y squared plus y to the fourth. And that's still going to be greater than or equal to 0 since I didn't do anything else. And adding 2x squared y squared to both sides, I get that x to the fourth plus y to the fourth is greater than or equal to 2x squared y squared. So now, if x to the fourth plus y to the fourth is greater than or equal to 2x squared y squared, if we flip it, that means 1 over x to the fourth plus y to the fourth is going to be less than or equal to 1 over 2x squared times y squared. So there we found an upper bound. And the lower bound is going to be 0 because x to the fourth plus y to the fourth is always bigger than or equal to 0. So 1 over that is still going to be bigger than or equal to 0. Okay, now going back to this, we have 0 is less than or equal to x cubed times y squared over x to the fourth plus y to the fourth. Because what I'm doing right now is multiplying three sides, all these three sides with x cubed y squared. And I'm putting absolute values. So technically, I forgot to close this absolute value over here. So the absolute value of x cubed y squared over x to the fourth plus y to the fourth, that's going to be less than or equal to x cubed y squared over 2x squared y squared. Now, the lower bound still remains 0, and we're still going to leave the middle term alone. But the nice thing about the right side is x cubed over x squared turns into x, y squareds cancel, and the 2 is still there. So what we're left with absolute value of x over 2 is our upper bound. And so now we could just take the limit of, both of these guys. But first, let's look at all the different cases. So if x and y are not 0, or if they're 0, then here we have the upper bound here. We have 0 is less than or equal to the absolute value of x cubed y squared over x to the fourth plus y to the fourth, less than or equal to absolute value of x over 2. So what I did was I took the absolute value of x cubed y squared over x to the fourth plus y to the fourth, and I removed the absolute value for most of these guys, except for the x cubed, because that's the one where, it could be negative. So that case is done. If x is 0 and y is not 0, that means that we could just plug in x to 0, and we're left with 0 times y squared over y to the fourth, which is just 0 over y to the fourth, and the limit is 0. If x is not 0 but y is 0, then replace y with 0, and we have 0 times x cubed, which is 0, over x to the fourth. It's still 0. So now we just need to focus on this inequality. So if I take the limit of all three sides, well, the lower bound here, that limit is going to be 0, obviously, and so it's going to be the upper bound, because if x approaches 0, then the absolute value of x over 2 also approaches 0. And so that forces the middle limit to be 0 by the squeeze theorem. So now let's put it all together. So we have the limit of this is equal to 0. If I add 1, the limit turns into 1. And I'm basically going to change this. I guess think of it as working backwards. 1 was, we said, was x to the fourth plus y to the fourth over x to the fourth plus y to the fourth. And then I'm going to remove the absolute value here. That doesn't really do anything. And so adding this together, we get the original question, x to the fourth plus x cubed y squared plus y to the fourth over x to the fourth plus y to the fourth. And that limit, as x and y approaches 0, 0, is going to equal 1. And so that's going to be the final answer.